75% of restaurant employees say yes. This is from a national survey. A random survey of one chain gave us the results of 68 of 100 surveyors saying yes. We want to know, is this particular chain less stressful? Is working at this restaurant causing less stress than nationwide? We're going to use a proportion test to figure that out. Going through the four-step process, very, very similar to what we've done in the past. Just a few tiny tweaks. Here we go. Step one, we're going to establish the population and parameter of interest. So remember, population's a reflection of your survey. So if we're serving one particular chain, our population is all employees. It's all employees of this chain of restaurants. My parameter is the true, and here's a difference, the true proportion, it's capital P, of stressed workers. Our null hypothesis is that there is no change, so we are going to take this 75% from our prompt and use that in our null hypothesis. And again, we're talking about proportions, so I'm saying P is equal to 0.75. There's no change, no difference between this chain and the rest of the nation. Our alternative hypothesis suggests that there might be a chain. We want to know if these employees are less stressed. So is the proportion less than 0.75? And let's stick with our alpha, our significance level, of 0.05. Anything that happens more rarely than 5% of the time will be impressive enough for us to change our opinion about the null hypothesis. Step one. Step two is our conditions, and our conditions remain the same from hypothesis testing that we've done before. So we need to, one, establish that our information, our data comes from a simple random sample. Two, show that we can use our table A because our distribution is normally distributed. And three, we need to establish independence so we know that we're not over-pulling from our population. Simple random sample, it was stated right here in the problem, a random survey, so we just say stated. Normality is different for proportions. Normality is no longer proven by the central limit theorem. If it's not stated in the problem, which in this case it is not, we have to show normality by saying we have a big enough sample size. How big? Well, our sample times our hypothesized proportion has to be bigger than 10. And at the same time, our sample times the complement of our hypothesized proportion also has to be bigger than 10. So we're going to drop in some numbers and show that that's true. My sample here is 100. My proportion, my hypothesized proportion, that is that 75%, so 0.75, greater or equal to 10. And 100 times 0.25, greater or equal to 10. Of course, this is 75. We're good to go here. This is 25. We're good to go there. Excellent. Now, independence might hang us up. So, independence, the population has to be 10 times bigger than the sample. So, that means all employees has to be 10 times greater than our sample size of 100. Now, this is a non-specified chain of restaurants. So a chain means it's more than one restaurant. We're not just talking about Lenny's or or a local restaurant where there's maybe a handful, right? This isn't maybe a small chain like Zips. This is a big chain like something like McDonald's or Sherry's or something where there's many restaurants, many employees. And so if that's the case, then yes, we satisfy that condition as well. Step 2, normality. It's the only one that's different here. I showed in the previous video that step 3, our computation, our calculation step, is a little bit different than it has been for calculating a mean. Let's go ahead and look at that a little bit closer here. Z is equal to the sample proportion minus estimated proportion divided by the standard deviation of the estimate. All right, so that's really easy to say, but where does that come out when we're talking about our math symbols? Let's anchor it to something that we're used to. And again, you'll notice that Z, we're on table A. Sample proportion, that's P hat. What is our sample proportion in this problem? We're going to use these values right here, the 68 of 100. 68 out of 100, so that's really easy. That's 0.68, right? That's my sample proportion. This guy right here, that's P hat. Minus my hypothesized proportion, that's this dude here. Hypothesized proportion divided by the standard deviation of this hypothesized proportion. Dropping our numbers in, Z is going to be equal to 0.68 minus that 75% divided by the standard deviation of my hypothesis, 0.75 times 0.25 over my sample size of 100. I'm going to use my TI 84, you can use an 83 to do these calculations, so I don't mess up the order of operations in my calculator. If you're going to do that, please follow these directions. You are going to hit your stat button, and then you're going to head on over to tests, and then from tests you're going to go down to 1 proportion z-test. When we do that, you're going to drop in, your null hypothesis, that 0.75. X is the number of successes, so the 68 is the X. N is the number in your sample, so the 100 is your N. Our null hypothesis is the less than symbol because we want to know if this company has less stress, so that's the middle one. And then we're going to go off to calculate, and we see that Z is equal to negative 1.6, I'm rounding here, 2, with a p-value of 0.0529. All right, we're going to take those numbers into our conclusion and finish this problem out. Step 4, big finish. Here we go. Just like in hypothesis testing for the mean, we are going to have our 3-step process for our conclusion here. So we need the evidence, we need to make a choice, and then we need to put that choice into the context of the problem. So our evidence, we had a p-value of 0.053, which is greater than alpha at 0.05. Not a lot more, but it is more. We didn't quite meet that threshold. And so our choice must be to fail to reject the null hypothesis. And that null hypothesis was that our stress was the same. So here's the context. There isn't significant evidence to suggest difference in stress between this chain and other restaurants. Though we're really, really close, right? 0.053, we might put an asterisk on this and say, even though we failed to cross the threshold of our significance level, larger sample sizes might give us more accurate results. Maybe there is an effect, it's just not big enough to be shown with a significance level of 5%. But there it is. 4 steps, proportion testing, you're going to be just fine.